Welcome to all of you. In this session, we are going to have the design and implementation of digital low-pass FIR filter using the windowing method to meet the given specifications and its simulation using the Scilab. Now let us go through a problem related to the FIR filter design. The problem statement: obtain the coefficients of an FIR filter to meet the following specifications using window method. Passband frequency 0.375 pi radians per second. Stop band edge frequency 0.5 pi radians per second. Stop band attenuation, it is 50 dB. Right? So these are the given specifications that are being noted as part of the solution. Since it is the 50 dB attenuation, it belongs to the category of the Hamming window. Now finding the order of the window, this is the formula. In order to find the order of the window, we are going to get the 64 as the order of the window. So since the order of the FIR filter must be an odd number, we are going to round off to the next odd number, that is n is equal to 65, because we need to have the exact midpoint. So because of that, we are going to have the order n is equal to 65. Now identify the cutoff frequency as well as the midpoint alpha. Cutoff frequency omega c, we are going to consider it as the passband itself. Therefore omega c will be equal to 0.375 pi. We are going to have alpha is the midpoint. So midpoint alpha is given by n minus 1 by 2. By substituting the values, we are going to get 32 as the midpoint. Now we need to first find hd of n and then the window function w of n. hd of n is given by this formula, and the window function is based on which window we are going to make use of. In this particular problem, we are going to make use of the Hamming window. For Hamming window, this is the window function we are going to get. Once we calculate the values of hd of n and w of n, we are going to multiply them and we are going to get the final impulse response h of n. Now with all these substitutions and values, we are going to have a tabulation. Now this is the tabulated values of it. Total 65 values we need to calculate. That is as per the order of the filter we are going to get 0 to 64. Right? So here it is shown at n is equal to 0, 1, 2 calculated. Then middle three values 31, 32, 33. Last three values, that is at n is equal to 62, 63 and 64. hd of n, these are the values we are going to get, and window function, these are the values we are going to get. Multiply these two values, this is what the result we are going to get in complete. Now let us go through the Scilab simulation, but before that, where the point to be verified, at the midpoint, that is at n is equal to 32, always we must get the highest value, and before and after there must be the lesser value, as you can verify. So before this midpoint it is 0.293, after midpoint 0.293, these two are same. Similarly, the first value and the last value, that's at n is equal to 0 and n is equal to 64, values must be same. At n is equal to 1 as well as at 63, it's the same. So that means with respect to midpoint, if you perform the folding operation on either side, the values must be the same. Now let's go through the simulation for the same. Now in the program, we are going to provide the order of the filter and the cutoff frequency as input. Then we are going to calculate the midpoint alpha given by this formula, and then we are going to calculate hd of n. If the n value is equal to alpha, then this is the formula being used. If it is not, if n is not equal to alpha, then this is what the formula we are going to make use of. By using this, we are going to calculate the hd of n values, and then after we need to calculate the window function. For that, we are going to make use of the inbuilt function window of HM within single quotes comma N. So this is going to indicate which is the windowing technique that we are going to make use of. So in this particular problem, we are going to make use of the Hamming window. Therefore, HM is being used. If it is the Hamming window, then HN has to be used. For rectangular window, RE needs to be used. Right? So once we have got the window function, then we are going to plot that windowing value over here and its magnitude plot over here. Right? These are the two part of the program in order to have the profile plot of the window function and the magnitude plot of the window. Then after we need to calculate the h of n, that is given by this formula. That means hd of n, what has been calculated, and the window function that has been calculated. If we multiply those two, we are going to get the impulse response h of n. The values will be displayed as well as the plot of those values. The h of n values will be plotted over here and its magnitude response is plotted in this part of the program. Now let us go through the simulation for this one. So the order of the filter, we are going to take it as 65 is the order of the filter, and then 0.375 pi is the cutoff frequency, is what we have taken in the problem. Same we are going to use here also. So which are all the values that we are going to get? So they are all being calculated over here. Right? So as we can observe, so hd of n values that is being calculated over here, and then after this is the window function values that has been calculated, and this is the final impulse response that has been calculated. And as we can observe, so here is the highest value, that's the midpoint 0.375, and on either side of it, it's the similar values and what we had gone through in the theory calculation. So same values are available here also. So similarly, this value as well as this value must be same. Then the first value and the last value must be same. So like this, we can, with respect to midpoint, if we perform folding operation, the values which overlap on each other, they must be same. Now let us go through the graph for it. Now this is the graph with respect to the windowing values, window function values what we have calculated. This is the profile plot and this is the magnitude plot of the Hamming window. Now the final window function, after multiplying the window function and hd of n, this is what the answer we are going to get. And if we just elaborate it, we can identify that at the midpoint, that is at location 32, we are going to have the highest value, that is 0.375, and on either side we are going to have the same value as we can observe over here, 31 and 33 same values. Like that we can just keep comparing the values over here, right? So in this graph we can just try to identify what is the at 50 dB, what is the value we are going to get with respect to the x-axis. So almost approximately if we take at 50 dB, so it is around x-axis frequency 0.213 we are going to get. Thanks for joining.